Hi everybody. Today we will continue with the classification topic. We will talk about non-binary classification. We are going to talk about decision tree, forest model, and boosted model. In this session, we will use the same business problem and the same dataset as the learning videos. So we have a dataset about employees in one of the companies. The business issue here is that the insurance company of the mentioned company has some kind of reward program, but this reward varies, depends on the type of transportation of each employee. So the company did a survey or sent a survey to ask its employees what kind of transportation they use. Only 60% of the employees responded to that survey. What we are trying to do here is to use the survey dataset to create a model to predict the transportation type for the rest of the employees, or the 40% that didn't do the survey. So this is the survey dataset for the 60% of the employees. So we have employee ID, gender, age, marital status, drive distant miles, and mode. So we are trying to build a model to predict the mode here. Mode is our target variable. So this is an Alteryx database file, but let us check the field type anyway. So I'm gonna use select as usual. Select. So gender, string, age, double, marital status. Everything seems fine. Okay, so we're good. Now let us also, as usual, let us try to understand more about our data. The distribution, missing values, all this kind of stuff. We can use summary field tool. So investigation, field summary tool. All the field, but I don't need employee ID here. It's really just like row number field or something like that. So let me add browse tool after interactive report. So let us check the missing data. So that's good. No missing values here. We can see when we check the green bars. So 100% available. Okay, let us check the target variable. This variable has only 3 unique values: car, public transportation, and bike. So we have 3 unique values or categories, or we can say classes. So we are trying to predict a category, and we have only 3 potential outcomes. So it's a non-binary classification scenario, and we can run models like decision tree, forest, and boosted. Also, we can see here most of the employees use cars, then public transportation, and a few use bikes. Anyhow, we also have gender and marital status. These are categorical variables. And we have age and drive distance miles. These are continuous variables. We can say that we have a normal distribution. Let me see. We don't have any skewed data here. Maybe only this one. This is abnormal. Uh, Distance between 10 and 12. Okay, that's weird. So usually we need to see or we need to check the reason behind this issue and if it's normal or there is something wrong with our data. But during this session, we will not do that. So we're gonna leave it as it is. Anyhow, the data is good. Now, let's start building our models, our predictive models. So first we need to divide our data set to train and test or estimation and validation sets. We can use create samples as usual, 70% for estimated or estimation dataset and 30 for validation. Again, don't forget to set the random seed always. Okay, now we're gonna try three models here: decision tree, decision tree, posted model, and forest model. So I'm gonna start with the decision tree. Okay, decision tree. Yeah, before I forgot, always remember that we need to check the tool version. We need to select version 1.0. Okay, let us do the configuration. So our target variable is mode. Gonna select all the available except employee ID and the target variable itself. So we're gonna give it a name decision tree. I believe now we're good. Okay, I'm gonna add after report and let me see after interactive report. Let me run it. Oh, you know what? Let me add the forest model and the boosted model so I can run them all together only once, so we don't have to run our workflow many times here. So forest model. Again, mode. Okay, I'm gonna keep it 500. We're gonna see how we can customize this later on. Okay, I'm gonna add after report. We only have one report here, so I'm gonna give it a name, forest model. Okay, posted model. Okay, posted model. Did I select the right target variable? Yeah, I did. Okay. And browse tool after report. Yeah, in the configuration area on the second tab here, we need to change something. We need to choose this checkbox and we need to choose multi-nominal, not binary or continuous target. So because we have three categories here or three potential outcomes. So we need to choose this choice. Now we're good. So let me run all the models. Now remember, the forest model is just a developed version of the decision tree model. It creates hundreds of trees to reduce errors or to deal with the overfitting problem. For the boosted model is also just improvement on decision tree. But instead of creating many trees like in the forest model, in this model, it does some kind of analysis at each split or step and try to find an error, uh, uh, try to change it or fix it in order to reduce the error rate. So it's gonna take a few more seconds here. Okay, well, good. So let us check the first one. Decision tree. Okay, we have the confusion matrix. That's pretty good one, 96% accuracy overall. Okay, that's very high percent, but remember, this is the estimation data set, and we know that decision tree tends to overfit the model. Anyhow, we're gonna check and validate this model later on. We have also, let me see, variable importance plot. You can see the continuous variables are very useful here in our model, while gender and marital status, these are not very useful variables in decision tree model here. We can see the split of our tree also. Okay, not a bad result. So let's check the forest model. Here we have a very important measure, out of bag estimate or out of bag error rate, which is 1.8 here. That's very good one actually. So this is like using the out of bag error rate. It's like using R squared in regression model. This is a value to decide whether we have a good model or not. We also have the confusion matrix here, and we have the classification error for each class. So we have 0 here. This is very good one. I think I made a mistake. Let me check again. 500. Okay, I'm gonna go with it. You know what? Maybe I need to choose this one. Oh, here is my. I thought I made a mistake here because it's very good model. Yeah, I chose employee ID instead of gender. Anyhow, let me run it again. I'm sorry about that, guys. Oh, I made another mistake. Stop, please. So let me add after report. A few seconds more. Again, I'm so sorry about this mistake. Okay, well done. So, yeah. So, uh, out of bag error rate 3.5. Yeah, it's more like this one. So we have very small error rate for bike and for cars, but we have about 10% error rate for public transportation. Anyhow, it's not that bad. It's good. It's good rate after all. So we also have this plot. So we can say we have overall accuracy here about 96%. Uh, it's like the decision tree model. We have this plot also percentage error of different number of trees. Actually, this is very useful chart to determine the best number of trees to be used in our model. Uh, we need to look for a value that minimize our error for each one of these options, for each one out of bag, bike, car, and public transportation. So when we can see a flat line, we can say that, let me see, we can say that after like 103, we have flat line or flat lines, let's say. We don't have any real improvement or reduction in error rate after 103. For safety, you can choose 150 or 200. I'm gonna stick with 100. So I'm gonna go here and change this 500 to 100 so we can save some time when we try to run our workflow again. Yep. So what else do we have? Also, we have variable importance plot here. The same one. We have drive distance miles and age. These two variables has a very good value in our model, not like gender or marital status. So yes, boosted model. So we have two plots here. We have variable importance plot. See here, the model only used drive distance miles and age. It didn't use the other two variables. Okay, let's talk about this one. Number of iteration assessment plot. We use this plot to answer how many trees are needed to has the best results. So we can see the blue line here, and it tells us we need 4,000 trees. This is a huge number. Maybe that's why it took a long time for Alteryx to complete this model or to run this model. Yeah. So now after we check the measures for each model, the next step is to validate each model as usual. So we can add a comparison tool. Where is it? Decision tree. Model comparison tool. So, but before that, I need to use union tool to union all the models. Then the union tool to input and data to validation. Oh. What's going on? Oh, really? So, and here we go. Let me check if we did everything correctly. Yep, yep. So, let me add browse tool after report. And let me run it. So what we're gonna do here is we will try to compare the result of each model with the original result. So we're gonna validate each model separately. Then when we're gonna compare the three models to see which one has the best result. By the way, many students had a problem with the comparison tool. So if you have any, please send me the error you have. I've seen like 2 or 3 different kind of errors related to this tool, and each one needs different solution. So if you can take like screenshot of your error and send it to me, we can talk about it. So, few more seconds. Maybe, okay, we're done. That's good. So, validation. Okay, let's talk about decision tree first. So here we have overall accuracy 83. See the normal problem of decision tree, which is overfitting. Remember, we had 96% accuracy on the estimation or estimated model. Here it's much lower. So yeah, but it's not so bad. After all, it's 83% overall accuracy. What about the, let me see, forest model? We have it 85 here. Well, it's better than the decision tree, but again, it's much lower than the estimation model. Also, we have it like 96.5 on the original model of the forest model. So we still have overfitting issue here. Anyhow, okay. Now we compared each model to the original model. Let's see which one has the best numbers here or best measures. Overall accuracy, let me see. Actually, all the 3 models have a, let's say, close result. Forest model maybe is slightly better, 85, while 83 and 83. Anyhow, in this course, we depend on the overall accuracy. We depend on this this measure. But what I would like to do is to check the accuracy in each class or category. I'm talking about this one. Uh, because sometimes we have a dominant class which could play a huge part in determining the overall accuracy. Let me give you examples. One example, let's say here. In our case, we have a dominant class or category with car. Most of the employees use car in their transportation. So uh, let's talk about decision tree and boosted models. So the decision tree have much better accuracy with bike, have less accuracy with car, and better accuracy with public transportation. So we have here about 4% better, here 4% less, and here we have like in 16% better. But the overall accuracy is the same because this class or this category, the car, have much records more than the public transportation or bike, and that's why 4% more here for the boosted model make it the same. Anyhow, let us go back to the big picture here. It seems like the forest model has the best overall accuracy, and it also have a very good accuracy with bike, car, and public transportation. So we're going to consider this one as our best model. Now, the next step, we need to score the model or to predict the transportation mode for the 40% of the employees. All we need to do is to first let me delete those. We don't need those. So now I'm gonna add a new data set. So this new data set contains 40% of the employees that didn't do the survey. So, and we need to predict the mode for them. So, you see, we have the same data, the same fields, but we don't have the mode here. Anyhow, this is an Excel or CSV file, I think. So we need to check the data type. Select tool. Yeah, we need to change age to double and distance to double also. So I'm gonna use score tool. So model input and data input. Okay, let me run it now. Okay, let's check our result. See, as in the binary classification section, we have probability for each class or category. See here, So again, as we did in the classification binary classification model, we can use formula tool here. You know what? I'm gonna just add one column instead of 3 columns with zeros and ones. I'm gonna just add one column contains the prediction, whether it's by car or public transportation. So I'm gonna call it prediction. I'm gonna use if. I'm gonna use this one. So let's say if spike greater than x public transportation and also x spike greater than x cars, then I'm gonna say bike, else if x car greater than x bike and x car greater than x public transportation, then our answer will be car. Otherwise, our answer will be public transportation. Okay, so let me run it again. So see, this is our prediction. Usually you add 3 columns with zeros and ones, but I like it this way. Usually I like to check my formulas if it's work or not. I like to check it because, you know, mistakes happen. So let's take this one for example. The higher probability is for public transportation, and our answer is public transportation. So let's check this one, bike. Let's see the bike here, the highest one, public transportation. Yep, just few random records. We can check them. Here it's public transportation. Let's take this one. Yep, so the formula is working perfectly. So I need to calculate the total count for each class. We can add summarize tool. We can group by prediction, and also we can count prediction. We can run our workflow for the last time. So let me see. So 141, 911, and 483. This is our final result, or the result we are looking for. So we checked our data. First, we applied 3 different types of non-binary classification models: decision tree, forest model, and boosted model. We compare the original model to the validation model. Then we compare the 3 models. We choose the forest model, we score the model, and we calculate the total count per class, and that's our prediction. So we're done for today. Our session, our learning session is done. Now I'm gonna take your questions if you have any. So just let me stop broadcasting and start taking your questions.